Now, you got 2 lessons on applications of integration. This is the first one, looking at total change. Now, linking back to what we learned in differentiation, the marginal change. So what you need to do is basically use your knowledge of integration to calculate total change in practical context, including measurement, motion. We'll talk about motion a lot more tomorrow. Not tomorrow, whatever it is, Wednesday. And then chemistry, biology, economics. All right? So now, let's look at total change, also known as net change. So if you consider a derivative function f dash x, if you want to know the change in fx when x changes from a to b, we can always integrate f dash x, correct? So we do have a definite integral. Go back to your fundamental theorem of calculus. Yeah, we have a definite integral. So this definite integral of f dash x from x equals to a to x equals to b gives the total change in fx when x changes from x equals to a and to x equals to b. So this time it's no longer the area. You're looking at the total change of the function fx, but we are given the derivative function f of x, or the rate of change. Yeah?
What if like b is less than a?
B is less than a is going to be, you got to tilt it around, pretty sure, to get the negative or the negative effect. You got to change it around. All right. Now let's prove it. So I want to prove it to you that that works. So given the rate of change of profit for selling X items is given by that, can we derive a profit function P? Of course. And can we use it to calculate the total change in profit when we increase the number of items we are selling from 5 to 10? So let's do the first step. First step, can you please find the profit function P, please? We know we've got P dash X, we know that. The thing is, we don't know the initial condition. But let's just quickly do the profit function P first. All right? You should be able to do the integration. And it should look something like this. Do you agree? Yeah? Now, the thing is, this is a fixed cost. Correct? In terms of profit, this is a fixed amount. Yeah? So let's think about the fixed amount. What happened when we change it from 5 to 10? That itself, we'll see what happened. So if we want the increase in profit, we need to find the profit when we've got when we sell 5 items, and then we look at P10 when we sell 10 items. Right? We've got P10 and P5. So here we could work out the profit, which is P10 minus P5, because when increase the number of items from 5 to 10, we just want to know what's the increase from 5 to 10. C. Now, what happened? What happened to the C? The focus question now. Is the C important in this case? C is not important in this case because we are looking at the total change. The change from 5 to 10. All right? We are looking at the change, so because this is fixed for both of them. So it's like moving the whole thing up and down, or that's all.
Yeah.
So that's fixed, so you don't really have to worry about the C. And we could write it in terms of the fundamentals of calculus, theory of calculus. So therefore, P10 minus P5 is actually Px, the function of x, 10 to 5, and or integrating P dash x, and I've proven it to you. We could write it as definite integral format. All right? So let's start off by looking at some examples. Example 1. Now, example 1, you've got to think back when we actually look at the marginal cost, the marginal revenue, and the marginal profit. All right? So what we did was in differentiation, we look at if we know a cost function, dc dx, or C dash X is actually the marginal cost. Right? It's the same with revenue and profit as well. And then you got to think about profit. Profit is revenue take away cost. Correct? Those are the things that I've discussed in differentiation, which you have to bring it back to here. Now then calculate the total profit from the production and sale of the first 20 valves. So we started off with 0, x equals to 0 first, and we want to look at what is the first 20 valve. What's the total profit from selling first 20 valve. So think about, you've got your cost function, the marginal cost, and you've got the marginal revenue. So I could actually think about working out a total cost, which is, start off with total cost, which is integrating that, all right, from 0 to 20. Do you agree? So I did not put both straight into profit. I'll work out the cost first, and then I'll work out the revenue. Or if you like, you can straight away write P dash X, which is the profit, marginal profit, is actually this, take away that. You could if you want to, but for me, I prefer to do it as a cost first and as a revenue. That gives me less margin of error. All right, I don't have so much error if I do that. So I can focus on the cost first. So with doing that, you know the cost for manufacturing 20 items, 20 valves is $340. Right? And then I work out the total revenue. Again, I integrate the marginal revenue from 0 to 20. Once you've done that, you can work out the total revenue is 840. And then you can work out the total profit is total revenue take away total cost, which is $500. Now notice we could actually use a delta symbol. A triangle, a delta symbol. Delta B equals to delta R minus delta C. Alright? That is alright if you write in that, if you use the delta. The total change, if you use the delta, that's fine. Alright? Example 1. That's the most basic example. Let's look at example 2. I want you to try this out. Try this one out. Following World War II, there was a significant increase in birth rates among the Western countries. It is assumed that the rate of birth in millions of baby per year for the post-war year is whatever. Alright? So you're given the rate. This time think about the rate, then we want the birth. We want to think about how many births there are. Now, I highlighted the word millions because when you answer a question like this, you must answer in terms of millions. Alright, millions of babies. So can you work out how many babies were born in the first 15 years after the war? You've got the bound here, 0 to 15. So you know the rate, you want to know the number of birth. What do? You integrate. You need to integrate this. Now if you actually integrate that, I wrote down as delta B this time, just make life a little bit easier for myself. Instead of writing the change in B from 0 to 15.
300 million babies.
Yep, 300 million babies. It's all the Western countries. That's, in the big scheme of things, I don't think it's a lot for 15 years. I think that would be the baby boomers era.
I really don't know.
I think. All right. So now, part B. How long did it take for the number of babies born after the war to reach 104 million? You need to use the same thing as well, but this time, you're going from 0 to whatever. Could be x, could be whatever you like. You don't have 15 anymore. So you now know you are going to integrate to 0 to x to 104. Obviously, use your class pad. Or if you don't use your class pad, I think you can solve this one as well without class pad. I'm pretty sure you can solve this one without class pad. It's just basically factorizing. All right? This is just basically factorizing. Honest. So, integrating 2t plus 5 is t squared plus 5t. So you substitute, you get x squared plus 5x minus 0 equals 104. So therefore, you can rewrite that. Factorize it. So 2 number adds up to 5 and multiplies to minus 104. I can use your class pad to factorize as well if you know how to do it. If not, you're going to try it out. So 8 equals x minus 8 or x equals to minus 13. Now, here, you must reject minus 13 because t doesn't go back in time, right? Negative number will not work. So you can solve for x, you'll get a positive and negative number, 8 or 13. So you've got to accept 8. Now, once you accepted 8, you must answer the question. The question, then you have to say that it took 8 years for the number to reach 104 million. All right? You must do that.
Wait, no, the original function. 2x plus 5.
Now, example 3 and example 4 will probably be very complicated. All right? I want to go through example 3 and example 4 very carefully. 3 and 4, you need to do it very carefully. Are you all happy with 1 and 2?
Yes.
Thank you. All right, let's look at example 3. Now, let's read this question carefully. An oil tank is drained of oil such that that if we kiloliters of oil are in the tank t minutes after draining commences, then dV dt equals to 2t minus 20. The initially full tank is empty in 5 minutes. Now, you've got to think about the question here. So dV dt, the change in the volume in the tank, t minutes, is that, the rate. So now you've got to think about what is the volume in the tank. And also here, the initially full tank is empty in 5 minutes. All right, this is another fact that you need to know. 2 things. So first, determine the number of kiloliters of oil drained in the first minute. Read the question carefully. First 4 minutes, and then the 4th minute. All right, so you got to be really careful between number 2 and number 3. First minute, you're integrating from 0 to 1. First 4 minutes is integrating from 0 to 4. Correct? What about the 4th minute? Where are you integrating from?
3 to 4? No, 4 to 5. 4
3
to
to
5.
4, 3 to 4.
Which one?
3 to 4.
4th minute. First minute is at 0 to 1.
0, 1, yeah.
Second minute is
2.
1 to 2.
2.
Third minute is 2 to 3.
4 to 5.
Fourth minute is 3 to 4. 3 to 4. So this is the tricky bit, all right? We'll talk about that later. So if you could integrate first, 4th, and that. So 4th minute is 3 to 4. First minute, 0, 0. Think about it here, 0 to 1. All right? From 0 to 1, that's first minute. And then 0 to 2, 0 to 3, 3 to 4, or whatever, okay? 0 to 1, 1 to 2, 2 to 3, 3 to 4. All right? Make sure that you understand how I worked out between 3 and 4. The thing is, once you know how to do your first integration, The rest is just substituting the number in. All right? It's a matter of interpreting the question. Now, also, you will work out the answer is minus 19. Here, you actually have to say that 19 kiloliters of oil has been drained in the first minute. So answer the question. The minus 19 doesn't make any sense. All right? If you don't explain it. So you could explain that the minus 19 because it's flowing out.
Yeah.
Therefore, it's 19 kiloliters has flowed out from the drain from the tank. All right. This you would know how to do. This is the extra bit that you need to be able to explain why the minus is there. The minus is just the volume. How much is it been drained? So if you think about this is the tank. All right, it's initially full. So after first minute, this much has drained off. Second minute, third, and then the fourth. All right. So the second one is a cumulative 1, 2, 3, 4. And then the third one is just between that. First one is between 0 and 1 minute. So think about step by step how much is drained. So once you've done A3, I will actually talk about B. B is again interpreting the question. I'm pretty sure all of you should know how to interpret the question, right? You should know the integration, but interpreting questions sometimes it's a little bit trickier. So part A2 is 64 kiloliters drained out of the tank in the first 4 minutes. And then finally, the fourth minute is 3 to 4. All right? And it's minus 13. So in the fourth minute is 13 kiloliters of oil. Now, part B. Here, it says that the initial full tank is empty in 5 minutes. So, within 5 minutes, this whole tank is emptied. There's nothing there. All right? The whole tank is empty. Agree? Yeah? So, therefore, if I integrate 0 to 5, I will get the capacity of the tank. Correct? Yeah? I get the capacity of the tank because I know that given that the tank was drained in 5 minutes. So the amount drained is the same as the capacity of the tank when full. Alright? So this bit of information is so important to work out part B. You can see that the question, the nuances of the questions, how you interpret that. And then if you do that, you can say that the capacity is 75 kiloliters. You will find a negative value. The negative value is just a value, the definite integral. You need to be able to interpret the definite integral. If you can't interpret the definite integral, it doesn't make sense. Minus 75, what does it do? All right? It's minus 70, the capacity is 75 kiloliters. Yeah? So the application for integration is how you interpret the answer. All right? So I want you to spend about 2 minutes reading through question 4. Question 4, it's potentially an exam question. All right? Example 4. It's a long question, step by step. There are 1, 2, 3, 4, 5, 6 steps altogether. 6 things you need to do. Now, with this question, you've got to think about the rate at which the water flow out of the tank can be modeled like that. here, I'll explain it in a few minutes once you start thinking about reading the questions. Especially when it comes to evaluate that. So this is the rate of the volume of water flowing out of the tank. Alright? So realizing that you could have a situation here. This is flowing out. It could be something flowing in as well. Alright? It could be something flowing in as well. So this is a tank. This is modeling the volume, the rate of the flow out. Alright? So that is what you got to think about. So first one, what is flow rate at 6 minutes? It's just V-6. Correct? First question is normally leading you into the whole thing. See, the question is in part. So the first two, pretty straightforward. That is just substituting
Negative 96 liters.
T equals to 6. Then you need to be integrating that. Half an hour. Now, look at the question. The question says time in minutes. All right, highlight that. And liters per minute. Because you will have to change this to 30 minutes. Correct? You cannot do it as a half. 0 to half doesn't make sense. All right? Now, 1 hour, you know you need to change that to 60 minutes. All right? Now, here, there's also a constraint. 0 to 70. All right? Further down here, it says 70 to 80. What does that mean? So just like what I say, first 70 minutes is modeling water going out. All right. After that, could be water coming in as well. All right. That is something that you got to consider. See that here. Read set F1 and 2 determine the increase of water in the first 10 minutes after the tank begin to fill. So after 70, there will be inflow going into the tank. All right. Now we're going to think about what we need to do. So part A and part B, straightforward. Part C, we will start thinking about what to do. All right. Also think there were 6,000 liters of water in the tank initially. Its calculator assumed this one. Now, so if you look at this, the first thing, I actually calculated V-6. But what does minus 96 mean to me? Not much. You must interpret the question in context. Always answer in context. So water is flowing out of the tank at 96 liters per minute. As T equals to 6 minutes, this is what happened. All right? So you must think about the question in context. Always in context. And then you integrate from 0 to 30 and you get minus 3105. What does that mean? Nothing. You got to interpret it again. 3,105 liters of water flows out of the tank in half an hour or in 30 minutes.
What'd you get?
All right. Make sure that you know you always must
Wait, no.
do that.
Wait, this is for D? 43.97.
Yeah. So from there, Part C. I'm integrating from 0 to 60 because it's half an hour. Now, read the question. There was 6,000 liters of water in the tank initially. How much water is in the tank after 1 hour? All right? Heaps of people will have done this, integrate it, and say that it's 5,580. No, because that is flowing out. So you need to take away 5,580 from 6,000. All right? This is the bit that is tricky because you've got to interpret the question and you find that it's 420 liters water left in the tank.
6,000 on full.
All right? So that's quite important for you to think about how to answer the question.
Yeah, but
What is the question asking for? The question is asking for the amount of water left in the tank.
we're just doing this part, but that's the decrease in water, not the actual water in the tank.
Yeah.
So you've got to do the
Now,
original plus the
D,
decrease.
you get to think
Because
about
this will be negative, right?
D,
Equals
how long will it take to reduce the amount of water in the tank to a quarter of the storage capacity? So another bit that you need to think about how to calculate a quarter. All right. So you want 3/4 to flow out, which is 4,500. Yeah. You can work out a quarter and then 6,000 take away a quarter
40.
of that,
yeah.
or just
That's right.
make sure that straight away 6,000 times 3/4. That's amount that needs to flow out, and then you can do a integration. Work out what T is. Now, in this case, use your class pad. You need to use your class pad to solve. You need to use your class pad to solve. Who hasn't got a class pad? I should have asked. Anyone without a class pad? Anyone without a class pad? No? Everyone got a class pad? You need your class pad to solve. Use solve. Solve function.
Yes. I know you can't see.
You need to use your solve function. Solve, integrate. Now remember, you don't want this to be the same as that, all right? So if you use X, use Y for this. All right? Or if you use Y, X for this, solve for Y. It's up to you.
Yeah.
And if you use your class pad carefully, you should get 3 answers. Now,
3.
if you get the 3 answers, you've got to start thinking about what you need to reject. So you know from the question that minus is out. All right? Those two, what's happened? If you look at those two, am I allowed to accept 91.87?
No.
No, because the question said that the bound is between 0 and 70. Yeah? So therefore, you can only accept 43.97 minutes for it to reach 4,500 liters to drain out. All right? So you can only accept one value. You can only accept one value. You cannot accept all 3 values. So make sure that when you answer a question like this, give a reasoning why you reject those 2 numbers. All right? So it will take 43.97 minutes to drain 3/4 of the water. All right? You can answer it that way, or it will take 43.97 minutes for the tank to reduce to 1/4 of its storage. All right? So this is how you answer A, B, C, and D. You do know how to do the integration. It's a matter of applying it. How do you answer the questions? So now you need to evaluate V dash at 70. So the rate at 70 And also, you need to do your V double dash. All right? Why?
Because
It is telling us something. We are trying to use your idea of differentiation now.
water, that's
So when there's a differentiation,
the amount of water in the tank is available.
you can see that at 70,
Take away
the rate is 0.
the amount.
All right? And what happened is we do the second integration
That's 70.
is to determine whether this is maximum or minimum. All right? So it's flowing up until 70. So after 80, there could be water flowing in or oil flowing in. So if you think about it that way, V double dash 70, which is second derivative, is greater than 0. Therefore, at that point, the volume in the tank is at a minimum. And this means that the tank will start filling in for T greater than 70, not 0. It will start to increase for T greater than 70. Not 0, that's 70 there. Alright?
How do you know that?
That should be 70.
Because
Because the bound is 0 to 70.
Yeah.
So anything after 70, what happened is that's minimum. You work out the second derivative is 0.
Yeah.
It's greater than 0.
Yeah.
Whereas the first derivative is 0 there, which means that's minimum.
Yeah.
Alright?
So
Use
change.
your knowledge of differentiation now.
on the graph, right? It'll be like this. So
Alright.
you know here, it'll start increasing.
So from there,
So where's that water?
you can
Because it's a minimum turn point.
you can integrate 70 to 80 F1, and you'll find that that is 251.67. The increase is water. I should have answered the question. The increase in water in the first 10 minutes is 251.67 liters. I should have answered the question. I did not. All right, and finally, determine the net change, which is 0 to 80. From 0 to 80, so you're now thinking about the first bit, which is draining to 70, and then you're going to add in 0 to 80, and in the first 80 minutes, the amount of water in the tank has decreased by that much. All right, so first 80 minutes, although there's one going in, more going in after 70 minutes, but it has decreased by this much.
Net gain area.
So that's a net effect from 0 to 80.
We didn't.
It crosses the minimum
Yeah.
point and go up again, but it's still in the negative territory because there are more water draining out than going in. So like I say, question example 4 needs a lot of thinking, and this sort of question, you do know how to do the integration. It's how you interpret the answer. That's important. That's so important is interpreting the answer. All right? So I'm going to stop here. I've given you some exercises to do from Sadler and also from Nelson.